This conference will now be recorded.
Hello everyone. So we will start with coordination compounds, previous year's questions, and that is for JEE Advanced exam only. So here we have a problem. It is asking that the complex or it may be more than one. So see here the answer can be one or more than one. So that is it is written in this way, complex or complexes which can exhibit the type of isomerism shown by this complex. So it is not directly asking which isomerism, but the isomerism that is shown by this particular complex, we have to first find that isomerism, and then we have to see among these four options which or it may be more than one are actually showing this type of isomerism. So first focus on this complex, it is PT, and there is two different types of ligands. That means it is of type M A2 B2. Now for PT, when there is that is 4 coordination, as you can see here. So most of the time PT oxidation state 2 plus, it is mostly square planar complex. Now in square planar complex, if we have two different types of ligands, obviously you can understand what type of isomerism is possible, and that is basically cis trans. So the complex that I am drawing, this is basically trans. But if I am placing both bromine and 2 ammonia at 90° to each other, then it will be cis. So basically it is showing geometrical isomerism. Now we have to find among these ABCD4 complexes which are actually showing this type of isomerism. Come to the first one. Here we have EN and ACN. Now PT, when there is ACN, that means 2 ACN, and as there is ethylene diamine, that means one cis position is already locked, so it cannot show geometrical isomerism, it is cancelled. The next one is Zn 2 ammonia 2Cl. Now coordination number 4, and if it is tetrahedral, no question of GI, but is it tetrahedral or is it square planar? See here oxidation state is 2 plus. Okay, and Zn 2 plus means it is a completely filled D10 system, and in D10 system here square planar that is geometry is not possible. It is basically tetrahedral. So as it is tetrahedral, so cis trans not possible. Okay, so this is also cancelled. Come to the third one, PT 2 ammonia and 4 chlorine. Now here coordination number is 6. Now PT, if I am placing these 2 ammonia 180° to each other and all the chlorine, because there are total 4 chlorine, and here the type is basically Ma2B4. So for any Ma2B4, if it is octahedral, cis trans isomerism is possible. Here you can see these 2 ammonia, they are trans to each other. But suppose if I am replacing one chlorine, suppose if you replace their positions like this, now the 2 ammonia, they are cis to each other. So that is why here cis trans isomerism is possible. And what about the last one? Here we have chromium, 2 ethylene diamine, and 1 water, 1 sulfate. So what is the type? Here the type is 1 symmetrical bidentate ligand, sorry, 2 symmetrical bidentate ligand, and then B and C. So this is the type. Now for this type, if I am writing this bident, you can also draw it for this chromium complex, but I am just doing it for any general cases. So these H2O and SO4 as it B and C, these two are trans to each other, right? Now another possibility is if I am drawing these 2A, basically these 2A, that is ethylene diamine or any bidentate ligand, they will always be in cis position. Transposition for AA, that is I'm talking about ethylene diamine, that is not possible because to have a orientation, the length between 2A, it is not so high that it can be placed in transpositions. That is why they are always cis. Now only two places left, C, that is B and C. So these two are now 90°. So in this case, it is 180°. So here also GI is possible, that is cis trans isomerism is possible. That means these two options will be the correct options. Okay, we'll go to the next question. Match the electronic configuration which is given in list 1 with appropriate metal complex ions given in list 2. And here we have some information. Atomic numbers of these three metals are given: 26, 25, 27. Why it is given? It is given because it will help you to write the electronic configuration. The last fully filled noble gas for this 3D, that is the first transition series, that is basically argon. Now for argon, atomic number is 18. So if you subtract 18 from 26, you will get how many electrons you have to consider after argon. So that is the reason why it is given. But if you already can remember that is the total number of electrons present in 3D or 4s, then it is good. For example, when it is iron in zero oxidation state after argon, there is total 8 electrons extra. Okay, so that is why it is 3d6 4s2. Now when it is Mn in zero oxidation state after argon, it is 3d5 4s2. And for cobalt, zero oxidation state, it is 3d7 4s2. Okay, so that is why it is given. Now here, if you look at the options, P, Q, R, S, all are associated with either 1, 2, 3 or 4. Now 1 is extra, that is for 4 electronic configuration. You have total 5 complexes. So one of them must be extra. Come to the first one. When it is iron with 6 water and it is weak field ligand and it is neutral ligand also, so the oxidation state of iron is Fe2 plus. Now when it is Fe2 plus, basically it will be 3d6 system, and as it is weak field ligand, that means how you will place all these electrons, it is like this, right? So it is T2G4 Eg2. Now T2G4 Eg2, that you can find with S, so it must be S. The next one is Mn2 plus. Mn2 plus with 6 water, just like the previous case. Here oxidation state is 2 plus, and this will be 3d5 system. Water is weak field ligand. And see, even if you don't have to write the electronic configuration, I am just showing this for your convenience. But when you will be actually solving the questions in the exam hall, it is not always necessary. Sometimes if you are not confident, obviously you have to write. But even if you are not writing, it is okay. So 3d5 means what? When it is high spin complex, because it is weak field ligand, so obviously it will be symmetrical distribution, that is T2G3 Eg2, T2G3 Eg2, and it is matching with this one, that is Q. Now Q is matching with 2, S is with 1. That is present both in option C and D, but only one of the options will be correct. Okay. Next one is cobalt 3 plus, but here we have strong field ligand. Now when cobalt is 3 plus, it is basically 3d6 system. Now 3d6 system, and there is strong field ligand, so it will be T2G6 Eg0. Now T2G6 Eg0, it is matching with P. So P is related to 3, but that is also present in both the options, but we are left with only R. But that also we have to check because still there are 2 more complexes. Here iron FeCl4 minus charge outside the coordination sphere. That means their oxidation state of iron is 3 plus. 3 positive charge, 4 negative charge, 1 negative charge extra. When iron is 3 plus, it is basically 3d5 system, and we have here weak field ligand. Now for weak field ligand, when it is 3d5 system, it is 4 coordination. It is actually tetrahedral. Now it will be like this, and for tetrahedral we do not use the subscript G, it is E and T2. Now ET2, but how here we have total 5 electrons, so it will be E2 T2 3. So it is matching with R, isn't it? So that is why the first one is matching with S, the second one is matching with Q, then the third one is matching with P, and R is matching with 4. That means here this cobalt complex is basically extra. Option D, it is matching with all of these. Fine. So this will be the correct option. Next question. Read the question carefully It is very important. If you can solve this, if you can understand this, it will obviously help you to gain some clarity to how to solve this type of question. Because in JEE Advanced, there are different format of questions. So you must be aware of all these formats. Okay. So already you have seen some formats. Now look at this. Here we have two lists. And in list 2, one item is extra. That is fine. But here, one item from list 1, it can be related to 2 to 3 from list 2. What I am trying to say, suppose if you consider the first complex, chromium, it can be related to PQR or PQRS, or it may be related to all of them. Every possibility is there. Okay, so in this way it is there. But if you look at the option, suppose I'm saying option B is correct, and here it is mentioned that one is matching with R and S, but that does not mean that one is not, that is here C, Q is not present, but that does not mean it will not match with Q. So it may be matching with 3 to 4 statements in list 2, but sometimes less than that also can be mentioned. Now more we will proceed, what I am actually saying, it will be clear to you. So let's start. The first complex is chromium hexacyano 4 minus. Here 6 negative charge from cyano, 4 negative charge extra. That means here chromium must have oxidation state 2 plus. The next one, oxidation state, I'm just writing all the oxidation state. It is 4 plus because 6Cl, still 2 negative charge. Here water is neutral, so it is 2 plus. Here also iron is 2 plus. Now when chromium is 2 plus, under normal condition, here atomic number is given. After argon, it is 6 electron extra, and for chromium, the configuration is 3d5 4s1. Why it is so? Because half field stable configuration. Now, when it is chromium 2 plus, that means it will be 3d4. Now, for 3d4 with cyano, which is strong field ligand, right? So how will be the electronic configuration? See, after argon it is 3d4 4s0, and here it will be T2G4 EG0. Total 4 electrons you have to place like this. Del O is greater than pairing energy, so that is why actually this information is not required. Sometimes it may be required, but here it is basically during the calculation of CFSE. Here it is not required. Okay, pairing energy means to pair the electron there is some extra energy required, but here pairing energy is less than del O, so that is why you are able to do this pairing. So whenever there is pairing, you basically, if you do not have the previous information whether pairing energy is high or low, it doesn't matter. You just have to know whether the ligand is strong field or weak field, and we already know that cyano is a strong field ligand, so that is why you can do pairing, and whenever you can do pairing, that means del O is higher. Del O higher means placing the fourth electron in EG is difficult, but it is easier to pair this in T2G, so that is why del O is greater than P. Now come to the PQRST with which it is matching. It is P matching with P because T2G orbitals contain 4 electrons. This is true for this. Now Q is saying that 4.9 bm. So this value, when it is 4.9, that means 4.9 means what? It is, if you consider root over 25, it is 5. That means within root, it is something lesser than 25. That means it is possible with, if you consider it is as 24. Okay, so 24 when possible? When n value is 4, that means 4 unpaired electron. But here we do not have 4 unpaired electrons, so that is why it is not matching with Q. Is it matching with R, that low spin complex? Yes, it is low spin complex because of Cn, strong field ligand. Then here metal ion, it is not in 4 plus state, but it is D4 species. So that is why it is matching with P, R and T. Now out of P, R, T, if you look at the options, RT is present in option A. It may be correct. RS is present in option B. It cannot be correct because it is not matching with S. Option C, PR is mentioned. That is out of PRT, PR is there. So this is another possibility. But option D cannot be correct because it is Q and T. But here we do not have Q. Come to the next complex. So in this way you have to proceed. So that is why I am just explaining in this way. For the next complex, which is ruthenium, oxidation state 4 plus. Now ruthenium, it is not from first transition series, it is from the next series. And if you consider the position, if you know the position of iron, ruthenium is just below this, and then there is osmium. Now ruthenium, which is just below iron, obviously now you cannot write argon, it will be krypton. The last electronic, that is the noble gas, is krypton with 36. And here ruthenium, it is 44. That means here 8 electron extra, but it is 44. Why? Because it is 4 plus oxidation state, so 4 electrons will be lost. It is 44 5s, not 3d4s, because it is from the next series. Now the electronic configuration T2G4 EG0, just like the previous one, and it is also low spin complex. So it is matching with P. T2G orbital contain 4 electron. It is not matching with Q. Q not present here. It is matching with R because it is low spin. It is having 4 plus, so S is also present. T is also true. So it is matching with PRST. Now we have already cancelled on the basis of first complex. We have cancelled D, we have cancelled B. Now out in A and C, just check whether it is matching. It is PS. PS, okay, that is fine. And in C, it is RS. That is also possible. Now come to the third complex. In third complex, here we have again chromium, but with weak field ligand. This is weak field ligand. So again we will have same configuration, but when you will write in T2G and EG, now it will be high spin complex, not low spin. Now it is matching with T2G orbital contain 4 electrons. No, but it is having total 4 unpaired electrons. So 4 unpaired electron means 4 plus 2. It is root over 24, which is basically 4.9. So that is why Q is true. R is not true. It is not low spin. It is high spin. Metal and 4 plus? No. But it is D4 species. So it is matching with Q and T. What about the fourth complex? The fourth complex is iron with weak field ligand water. Here iron, as it is 26, that means 8 electrons. It is under normal condition, that is iron 0 is 3d6 4s2, but as it is 2 plus, it will be 3d6 only, high spin complex. So 3d6, you will place the electrons like this, T2G4 EG2. T2G orbital contain 4, it is true, P is true, Q is also true because we have unpaired electron n equal to 4. It is not low spin complex. R is not true. Metal and 4, no, it is not true. It is D4 species. That is, sorry, it is not D4 species. It is not true. Only P and Q, these two are correct. Now we have seen, we have already cancelled B and C. See, in the previous slide, we have already cancelled B and D. Now, if these two are cancelled, just check third complex matching with QT, that is present here. Fourth complex PQ, that is present here. That means this is not correct. RT and PT, this is not correct. Okay. So option A will be the correct option. So here one interesting point that you have to understand, for complex one, we have seen in the previous slide that it is basically matching with PRT, and for complex 2, it has similarity with PRST, and this is complex 3, this is complex 4. So only with complex 3 and 4, QT and PQ both are present. But if you see at the correct option here, out of PRT, only RT is present, but that is fine. You just have to check, and anything wrong is not present. That is here you can see nothing wrong is present. P is just excluded, but it is true that 1 is matching with RT. And here 2 is only P and S, that means only P and S mentioned, these two are excluded. So these are the type of question you can get. It is not that all the it is matching with PRST, so everything will be present. It may be present, it may not be present. Okay, so don't be let's just try to understand the pattern and format of these questions. The pair of complexes where both the complexes exhibit tetrahedral geometry. It may be is or it may be R. That is, out of options A, B, C, D, more than one option may be correct. Atomic numbers are always given whenever you will have any problem from coordination compounds. Now we will solve one by one. Here first complex we have FeCl4 minus. FeCl4 minus, just write the oxidation state. Here the oxidation state is 3 plus, right? Here the oxidation state is 2 negative. Why? Because CO is neutral. Now if it is so, when iron is 3 plus, 3d5. Now 3d5 FeCl4, that means coordination number is 4, and it will be basically sp3 hybridization, because the 5 electrons you will place like this. Why I am writing in this way? Because not in T2G or EG format, because in this way you can understand the hybridization. So this is 3D, which is full. Next you have 4s and you have 4p. So here sp3 hybridization is possible. So this is tetrahedral. Okay. The next one is a tetrahedral. In the next one, iron is having oxidation state 2 minus. Now under normal condition, it is 3d8 4s, sorry, 3d6 4s2. But when it is 2 extra negative charge, that means 2 electrons will be there. That means now it will be total 10 electron. And 10 electron, if you are fitting in 3D. Why you are fitting in 3D? Because now you have strong field ligand. So that is possible. So all the electrons now in 3D, 3D10, and you are left with 4s and 4p. So again we are getting sp3 hybridization. That means this pair will be counted as correct option. The next one, that is for the cobalt complex. Cobalt is having -1 oxidation state, and here we have +2 oxidation state. Now when cobalt is -1, it is basically normal condition 3d7 4s2. That means total 9 electrons. But now it will be total 10 electrons, and 10 electrons we can fit just like the previous case, and we are now left with 4s and 4p. So again sp3 hybridization. What about the next complex? CO2 plus. CO2 plus is which system? It is 3d7. Now when it is 3d7, it is weak field ligand. But still, if you are placing all the electrons, you will not have any d left. Because for 4 coordination, another possibility is square planar. And for square planar, there must be dsp2 hybridization. But here you cannot have dsp2 hybridization. And pairing of electron is not possible. So now again, it is sp3 hybridization. That means this is also tetrahedral and will be counted as correct option. Now come to the nickel CO4. Here oxidation state of nickel is 0. Here oxidation state is 2 plus. When nickel is 0, it is 3d8 4s2, but we will fit all the electrons in D. So as a result, for nickel, for nickel 0, now it will be 3d10 system. The condition is same as this condition when iron is 2 minus. Now you are left with only 4s and 4p. So again you are getting sp3 hybridization. So this will also be tetrahedral. But what about the next complex? Cyano is strong field ligand. So when you are having nickel 2 plus, which is basically 3d8 4s2, but because of that is transfer of electron will be there. 3d8 4s2, but it is nickel 2 plus. That means it will be 3d8. And when it is 3d8, pairing will be there, but you are left with 1d. So now there will be dsp2 hybridization. So this is not tetrahedral, so this you have to omit. Come to the next complex, copper pyridine. Now pyridine ligand, copper with one positive charge. Now when copper is 0, it is basically 3d10 4s1. So when copper is +1 state, it will be 3d10 only. Now 3d10 fully filled. So again sp3 hybridization. And for the next complex also, copper is having +1 oxidation state, 3 negative outside. That means again is copper 3d10. Here also sp3. So except nickel cyano complex, all the complexes tetrahedral. But look at the question, it is asking you have to choose those options where both are exhibiting tetrahedral. Now C is not both exhibiting tetrahedral, so ABD will be correct option. Now this is very interesting question. We will read the question first carefully. Obviously, you have to also check the picture as it is given. It is saying that in an experiment, m gram of a compound X, there is a compound X and we have taken m gram of it. It may be gas, liquid or solid. Basically, if you look at the option, it may be element also. Whatever, whether it is element or compound, we have taken it in a container. So here you can see m weight is on the left hand side and we have taken X on the right hand side. And we have loaded it in balance. As you can see, picture 1, here magnetic field is absent and they are balanced because both side weight is same. Now in presence of magnetic field, the pan we take is either deflecting upward, which is figure 2, this one, and another possibility, it is deflecting downward. That means it is coming towards the field, attracted. Second picture is there is repulsion. Last picture is attracted. Now that depends on the nature of compound. Now downward deflection, it is attraction, I am writing A, it is repulsion, I am writing R. Now repulsion will be there when it is diamagnetic. But when it is paramagnetic, there will be attraction. Basically, it is asking that among these complexes, what are, sorry, one complex is there. Actually, see, this question, though we are discussing under coordination compounds, only you can say there is some other compounds which are not complexes. Only one complex is there, but still we can discuss this under this chapter. So we have K4Fe6, which is complex. We just have to check whether it is dia or para. Then we have water, we have oxygen, gas, and we have benzene, which is liquid. Now, what about water? In water, if we see, is it para or dia? We have lone pair over oxygen, and oxygen total 6 valence electron. 2 electrons oxygen is using for bond formation with hydrogen, and rest of the 4 electrons they are as a pair. If you can also write the hybridization hybrid orbitals of oxygen, there also you will see these two pair of electrons that are not used for bonding, they are basically in paired condition. So here we do not have any unpaired electron. That means it must be diamagnetic. If it is diamagnetic, it must be moving upward, right? Repulsion. So this must be true. Now come to the next one, K4Fe6. If you remove all the 4 positive, K plus, there will be total 4 negative charge. 4 negative charge means oxidation state is Fe2 plus. Now when Fe is 2 plus, it is basically which system? It is 3d6 system. We have strong field ligand. That means it will be T2G6 and there is no electron. So all the electrons paired up. Again it is diamagnetic. So it should be also upward, isn't it? So this is also true. What about oxygen and benzene? Benzene also basically diamagnetic, but for oxygen it is paramagnetic. Now you can say why it is paramagnetic. If I write oxygen like this, there is 2 lone pair and 2 electrons are used like this. But see, the nature of paramagnetism in oxygen you cannot understand in this way. You just have to consider the molecular orbital diagram. It is basically paramagnetic. Fine. So see, if we look at the molecular orbital diagram of oxygen, here if you place all the electrons, 2s2, 2p4, this side also 2s2, 2p4. So to answer this question, we also need the knowledge of chemical bonding. And here we have sigma S star, sigma S, everything is fully filled. But when these 4 electrons from both sides, total 8 electrons you will be placing. 2 electrons, first you have to write single, then only pairing possible. So these 2 electrons are basically responsible for its paramagnetic nature. And benzene, though it is diamagnetic, because if you consider in sigma bond, there is no extra unpaired electron. And if you consider this pi bond, where the extra electrons over carbon, it is using for bond formation. And there is a pi cloud, right? So here pi molecular orbital diagram, if we see, that is only we will consider the 6 electrons that are involved in pi bond formation. Here you can see all the 6 electrons are paired. This is bonding. This side is bonding and these three are anti-bonding. So here also it is diamagnetic, this is paramagnetic. Now come to the previous information. Okay. So here the first one it is correct. The second one, that also we have seen it is correct because it is diamagnetic. Now oxygen, as it is paramagnetic, so it must be attracted. So this is also true. But for benzene, it should be upward, not downward, because it is not paramagnetic. So this is wrong. So here correct options are A, B, and C. Choose the correct statement or statements among the following. Here we have FeCl4 minus. Now we have already solved this problem previously related to this complex, and there we have already seen this is tetrahedral. You can check the explanation again. So I'm directly writing that this is true. Now what about the next one? COEN, 2 ammonia, 2 chlorine. Now what is the type of this complex? The type of this complex is MAA B2 C2, right? Now, two geometrical isomerism it is saying. Then we have FeCl4 again. Now just finish it. Okay. FeCl4 minus, it has higher spin only magnetic moment compared to another complex. So this complex is already in option B. Now for FeCl4, as it has oxidation state 3+. So when it is 3+, 3d5. That means you have total 5 unpaired electron. But what about this complex? Here oxidation state of cobalt is +3 because you have 2 Cl minus still positive charge. That means it is CO3 plus. Now when it is CO3 plus, it is 3d6. But we have strong field ligand, En and ammonia, 2 ammonia, 1 En. This is enough to overcome Cl. Cl is weak field, but we have 2 strong field ligands. So that is why it will be T2G6, EG0, T2G6 EG0. So it will have higher spin only magnetic moment compared to this one. That is basically true, right? And it has two geometrical isomer. So if we write this, so AA it will always be cis, right? In cis position. So this is one possibility. Sorry, we already have this. You can directly see there is actually more than two possibility. Here we have this AA, then we have both ammonia trans, these two Cs. Now in the last one, this position will always be fixed. So keeping this position fixed, just see how you can change the position of B and C. That is B2 and C2. So our B is ammonia and C is suppose chloride. So here these two are trans. Here these two are trans, chloride, chloride. But in the middle one, both are Cs. So we can say it is all Cs. It is trans with respect to ammonia, it is trans with respect to chloride. The middle one is all Cs. So it is more than two geometrical isomer. This is not correct. But be very careful. Don't consider the optical isomer, which is possible for all Cs. But here we are not interested in optical isomer. It is simply asking how many geometrical, which is more than two. So it cannot be correct. But next option is correct. What about the last statement? CO sp3, it is saying CO sp3 d2 hybridization. Now if we place all these paired electrons, we are still left with 2d. This is 3d, this is 4s, this is 4p. So you can have d2 sp3 hybridization. So this is not correct. It is not sp3 d2, d2 sp3, right? So first one is correct. C is also correct. A, C, these two will be correct options, not B and D. This question is very beautiful because this is interesting very. Here it is numerical type. So you just have to put an integer. It is asking the total number of cis nitrogen MnCl bond angle. So which bond angle? The angle between manganese nitrogen and manganese chlorine bond. That angle you have to find. But not just any position, in cis position. Present in the molecule of cis MnEn2Cl2. So first we will draw the complex. So En2 means what? They will always be in cis position, right? So remember, it has already mentioned it is cis. So if you are drawing like this, it will be completely wrong. It is not correct picture. The correct will be this one. Where the two chlorine, they are cis to each other. The first picture is not correct. This is trans. It is all had already mentioned cis. So this is the second picture you have to consider when you will find the angle. Now to solve this type of problem, it is very difficult if you are not numbering, because there are two types of chlorine, two chlorine, and there is different nitrogen. So if you are numbering the nitrogen and if you are also numbering the Cl, it will help you to count how many electrons, and there will be no repetition. So don't forget to put numbers. So you have to do it like this. Here we have number 1 hydrogen, number 2 hydrogen, 3 hydrogen and 4 hydrogen. It is not that you have to do the numbering in this way, that is up to you, but you have to do the numbering. So as we have used numbers for nitrogen, you can use some letters for chlorine. Otherwise again there will be confusion. Okay, letter for chlorine, number for nitrogen. Now just focus on chlorine A. Now chlorine A, what is its relation with N1? It is 90 degree. What is this relation with N2? It is 90 degree. What is this relation with N3? It is 180 degree. You cannot consider that. What is this relation with N4? It is also 90 degree. That means you just have to find all the C's, N, M and Cl. So that is why all these three, that is ClA with 1, with 2, with 4, but not with 3. This is cancelled. Now what about the other chlorine? For the other chlorine, the relationship of B chlorine with 4, it is cis, that is present. With 3 also it is cis. With 1 also it is cis. But with 2, it is 180 degree. So you cannot keep that. So these 3 for chlorine B and the first 3 that is for chlorine A. So total these bonds we are getting 6. So correct answer will be 6. The correct option regarding the complex, here we have cobalt En, 3 ammonia, 1 water. So what is the type? The type is MAA B3C, whatever is the charge. So this is the type. Why I am writing it? Because we have to find whether it has 2 geometrical isomer. Then see how it has changed in the option B. It is saying it will have 3 geometrical isomer if you are changing En with cyanide. Now when you are changing it with cyanide, the type will change to Ma2B3C, because now there is no bidentate ligand. All are monodentate ligand. So we will write geometrical isomer for these two. Now when it is MAAB3C, then the possibilities are, you always have to fix this position, BBC. Another possibility is, sorry, this is also B, because there are total 3 B. Now if I am just replacing one B with C, so this is another possibility. So it will be total 2. This is actually correct. Now when we have replaced it with 2 cyano, is there any change that we have to write? So for the other possibility, see here MAA, then we have total 3B. This is one possibility. Then another possibility, I am just fixing the position of AA again, but I am changing the position of B and C. So suppose C is now here. So this is another possibility. You just have to fix one part, then you can change the rest of the part. Now we will change the position of 2A. Now it is trans to each other, and under this condition, you will always have one condition. because you just have one C. So this is the one possibility. You cannot have more than this because total 3B. So one more possibility, when the position of A to A 180 degree under the, that is, it is trans to with respect to A. With respect to A, when trans, you have only one possibility. With respect to A, when it is sees, you have two possibilities. So now total will be 3. So this is also true. Is it paramagnetic? That is, it is asking about this complex. Is it paramagnetic? It is cobalt 3 plus with strong field ligand. That means it will be 3d6 EG0. It cannot be paramagnetic. Then it is saying that it absorbs light at a longer wavelength. Longer wavelength means low energy as compared to this one. So what is the difference between these two? Just check. Here we have 1 En, 3 ammonia, 1 water. Here we have 1 water replaced by another ammonia. So this will be higher energy because now we have more strong field ligand. So this statement is also true. So A, B, D, all these 3 statements will be true. Only C is not correct. The correct statement regarding binary transition metal carbonyl compounds is or are. The total number of valence electron at metal center. Now here we have neutral ligand. And for iron, they are and nickel both are zero oxidation state. When iron is 0, it is 3d6 4s2. That means total 8 electrons. Now 8 electrons, and from CO there will be 2 electrons for each CO. That means 5 into 2, 10. So it is 18 electron. It is not 16. So this is enough to cancel this statement. Even if you are sure about it, you don't have to do the calculation for nickel because you already know this is wrong. Partially wrong means also wrong. But you will also solve it. Nickel 0 means total 10 electrons, 3d8 4s2, if total electron 10. And from 4 CO, it will be 4 into 2, 8. Again, it is 18. So this is not correct. These are predominantly low spin. Yes, it will be true because CO is strong field ligand. Now, metal carbon bond strengthened when the oxidation state of the metal is lowered. Both are carbonyl complexes. So these two statements are basically for metal carbonyl complexes. So for metal carbonyl complexes, you have to know this bonding. So we know in metal carbonyl complexes, there is basically sigma bonding first, which is from ligand to metal. This is the direction. This is sigma bond. After this bond formation, there is metal to ligand in this direction. Now there is pi bond. Now when there is pi bond, the metal carbon bond, it is decreasing because now there is some extra bond. So metal carbon bond length decreases when there is back bonding. Decreases means what? Metal carbon bond is now having more strength. But this triple bond nature of carbonyl will lose because as there is electron donation, this bond order of C double triple bond O will decrease. That means CO bond length will increase. Now look at the C statement. It is saying metal carbon bond strengthened when oxidation state of metal is lowered. Oxidation state of metal is lowered means now there is more electron density. Suppose from +1 it is moving to -2, or from +2 it is moving to +1. Oxidation state is lower. That means it is more electron rich. When more electron rich means back bonding is good. Back bonding good means metal carbon bond will be strengthened. So this is also true. And the last statement is saying carbonyl carbon oxygen bond weakens. That means carbon oxygen bond length weakens means what? Bond length increases when oxidation state of metal is increased. Now this is not correct. When oxidation state of metal is increased, suppose you have metal 2 plus and then you are increasing to metal 4 plus. Now back bonding capability will be decreased because now the metal is electron deficient. When back bonding is decreased, CO bond cannot be weakened because now CO still have triple bond character. So this statement is not true. We have only true these two statements, not A and D. So we are at the end of the session. We don't have much time. And one more problem is there, but it will require more time. Okay, so we'll finish here. Thank you for listening.